Water management is tightly tied to the management of sodium. Water just goes where the salt is in your fluid compartments. The only fluid compartment able to exchange with the outside world is your plasma. The ICF, it's just a reservoir for water. We can take water or we can give water to the ICF compartment in an effort to maintain the ECF osmolarity. Even if you don't drink water during the day, or even if your water is coffee flavored, you you produce water during the day just from metabolizing your food. I mean, every time you make ATP, you also create a molecule of water. There are way more ways to exit the body than there is to enter it when it comes to water. These first four things here on the right: expiratory respiration, sweat, regular water loss through the skin, and feces. These are all outputs that happen every day with no choice. Obligatory water reabsorption in the descending loop of the nephron is the process of trying to take back any water that you possibly can. If you're secreting ADH, aldosterone, or angiotensin II, you have the ability to reclaim water by way of facultative water reabsorption. And you're extra lucky. You will take back even more water than you could. When talking about hormones, there are three major ones that affect the ECF volume and osmolarity. Remember, the target is to affect the ECF osmolarity, but we really can't do that without affecting the volume. Consequently, blood volume and blood pressure are affected by these hormones. So, why do I only have ADH and aldosterone listed here on this slide? What am I missing? Angiotensin II is missing. And that's because, aside from other things that it does, like systemic vasoconstriction, it also turns on both of these hormones. And both of these hormones act on the DCT and collecting duct. Aquaporins are inserted into the cuboidal cells of juxtamedullary nephrons, allowing for more water reabsorption, and little tiny NAK pumps are inserted into the cells of juxtamedullary nephrons in order to reabsorb more sodium. So ADH, its primary concern is conserving water. It triggers thirst. So it has the capacity to increase your water volume, but you might not respond to that emotion of thirst. So what ADH is more likely to do is to affect your kidneys and create really concentrated urine. This is going to conserve water, lower your osmolarity, and it's also going to raise your blood volume and blood pressure. Remember, along with more water in the balloon comes with more pressure on the vessels. No matter what you are doing, you are decreasing your plasma osmolarity with ADH. And decreasing it is usually a good thing in humans because we all live in a dehydrated state. We're land animals. That's how it works. At the same time that ADH is turned on, aldosterone was also probably triggered as well. Aldosterone acts also on the DCT, and it makes the nephron reabsorb sodium and secrete potassium. As sodium is reabsorbed, water comes with it, kind of taking away from everything that ADH is trying to do. So more water means more blood volume and more blood pressure. As for osmolarity, where we had ADH decreasing osmolarity, aldosterone increases osmolarity. But the reabsorption of sodium, it's far outweighed by the water that comes with it. This is where we have to discuss edema. Many of you have probably seen people with edema or swelling of the body area, usually in the legs. Edema is not the swelling of cells. Edema is the expansion of the interstitial space or the accumulation of fluids in the interstitial fluid compartment. When you get a bruise, you've probably damaged a capillary or two, and so all the fluids they start to leak out of those capillaries, and the venule doesn't reclaim it all. And this is why bruises they swell. Fluid is trapped in the interstitial fluid, and it's not being reclaimed by the lymphatic vessels in the area. For example, blood with the right amount of plasma proteins in it can keep fluids in blood vessels. People with liver failure that have low plasma proteins, they have a low blood colloid osmotic pressure, and that decreases their ability to reclaim fluids from their tissues. So their lymph fluids, their lymph vessels, can't maintain the drainage from the tissues either. And this means that water is not attracted to the blood. It doesn't want to be reclaimed in reabsorption because there are no solutes to suck it back into the blood on the venule side of the capillary bed. As edema progresses, you're basically bleeding out or losing fluid from your circulatory system. That's it. I mean, it is kind of like bleeding out. It's just all the fluids. It's not red blood cells or white blood cells, but all the fluids. And they get trapped in that interstitial fluid compartment. This creates something known as congestion. Peripheral congestion occurs in the systemic circuit, congestion occurs in the pulmonary circuit. And the word congestion refers to an abnormally high amount of fluid in the circuit. And of course, this excess fluid puts pressure on the heart and lungs and their ability to expand. As the fluid builds, the individual dies.